Hello everyone, welcome back. So this is Calculus 3 and in this video we are going to talk about 2.6 quadric surfaces. This topic is a very short and we're going to explore how to find out surface equation in three-dimensional space. So far we have been exploring vectors and vector operation in three-dimensional space. And then you also learn how to develop the equation to describe line and planes in three-dimensional space. So in this section, we're going to expand our knowledge of a plane and line into three-dimensional surface and its equation. Okay, so I will show you the example. Sounds a little bit abstract, but once we see the image and equation, we can find out a better understanding. So what they mean, surface. So in general, in three-dimensional space, we found many different shape. One of the example is a cylinder. So when you look at the cylinder in two-dimensional space, cylinder is described as a circle equation. And three-dimensional equation, cylinder is going to be look like this. So we actually have 3xyz. So we have this shape in three-dimensional space. So this image in two-dimensional space is a cross-sectional image, because when you chop the image of the three-dimensional, space, you will see only the cross-section of the shape. So in two-dimensional space, whatever the three-dimensional space, three-dimensional shape, will be considered as a cross-section. For example, if I have a cubic, the cross-sectional image of the cube is going to be the square, right? The cross-section image of the cylinder is going to be the circle. So these are described as a two-dimensional space, and this is a three-dimensional space. So cylinder is one of the example we can talk about surface. So in this section, we're gonna deal with a variety of shape, but let's take a look at the cylinder. So cylinder is a very interesting. So when I'm talking about surface, it's outside of the layer, right? That's the surface. And then actually, this is the same as like a plane, right? So if you have a two vector, right? And then if you can find out the plane, between those two vector, and then if you roll out, if you roll in, you can find out the cylinder shape, right? So it's a very corresponding image, when I'm describing the cylinder in three-dimensional space. So just I want you guys to observe, if you have, it's a very interesting observation. If you have two parallel line, this is a two parallel line, and then we can consider as a vector. And then if you bend it, and then you're gonna just connect the, those are two ending line, you can find out the cylinder. So I wanna describe this equation. I wanna write it, equation to describe this cylinder. So in three-dimensional space, you will find out so many different, geometric shape. You might find out like a little bit of cone shape, right? You might find out like a little bit like a bowl shape, half a bowl shape. There are so many, geometric shape, and then they have a surface. How do I write down the equation of it? So one of the example is a cylinder. So let's take a look at step by step. So just remember, this is one of the example. You can think about the surface, and the surface can be described as a two parallel vector or multiple vector, right? So you have a vector, you have a vector, you have a vector, you have a vector. If you collect all the vectors, you can create a shape in three-dimensional space. So based on that, so that's what I say, rulings and cylinders is one of the example. So in this example, I just want to give you guys the idea, what the equation, what each equation is describing in three-dimensional space. So x squared plus z squared equal to 25. I'm looking at this equation in three-dimensional space. And then we know that this is very similar to the circle equation, but we have a z variable. And then it seems like there's 3 different variable x, y, z. So think about it. We have x, z, and then there's no y, that's okay. But they're going to create a cylinder. And then if you don't see the y, right? So y axis, just consider it's gonna be the open area. So when you draw the cylinder, you have a couple scenario. This is a one way. We have x, y, z. So z can be the center, or you can think about x can be the center, or you can think about y-axis can be the center. So you have a couple options to draw this cylinder. So what I'm saying is, if you have a missing variable, in this case, y-axis is missing in this equation. So y will be the center axis. So we have x, y, z right there. We have x, we have a y, and z. So exactly y-axis is open because that's my center. And then you can find out the other, 5, 5 as an intercept on each x and z. So this is going to be the image of x second plus z second equal to 25. If you want to describe this z, this pink cylinder, you see that z-axis is a center. So therefore, x squared y squared equal to 25. That's going to be the equation. If your y-axis is a center, x squared z squared equal to 25. In other case, x squared x-axis is the center, then y squared plus z squared equal to 25. So there are, a couple ways you can, draw the cylinder depending on the center axis. So that's how you can think about it. So second question, I just want you guys to observe, what the graph and equation is, how they're corresponding to each other. Second one, b is equal to x squared minus y. So there is no second power except x. So this is going to be just quadratic. So when you solve for, so this is the equation. So this is a quadratic, and then it's a plane actually, and then depending on how you're bent, how you bend the this plane, you will find out the different shapes. So this is a corresponding to the entire plane. You have a corresponding parallel line, and you just connect them. And then this one, they're not connecting, right? They just bend it. So they just bend the plane. So in this case, you're just gonna have x squared. So x squared is going to be this. That's where you're gonna find out the quadratic on the x-axis. And then it's going to be z equal to x squared minus y. So it's a little bit abstract as you see that, right? This is not like we can think about, mentally. We actually need to simulate it. But I just want you guys to observe, none of the variable, it's like, z and y variable, it's in the quadratic, only we have x second quadratic. So it means that x at x-axis, this plane will be bent. That's what that means, okay? Because a quadratic is a parabola shape. So we are kind of like corresponding it. You don't need to exactly graph it, okay? So the last one, sine x, we are thinking all the equation in 3-dimensional space. So in 2-dimensional space, this is a sine function. And then if you think about it in 3-dimensional space, the same equation, this is the image you can, think about it, okay? So in this section, we are not really, calculating or evaluating, the number. We are just trying to observe, okay, so if I have a plane, right, it could be cylinder shape, it could be parabola bend, or it could be 3-dimensional of one of the trigonometric, functions. So everything came from the plane, which is the collection of a vector. So plane, we know that this is collection of vectors. This is a vector 1, I have a vector 2, I have a vector 3. So plane, when you have it, depending on how you bend it, You can find out the cylinder, you can find out this shape, or you can find out like this other shape. There are so many possibilities from, plane, bent, okay? So that's something we're observing. And now I'm gonna show you all the possible, surfaces, depending on the equation, you can find out different shapes. So I'm gonna show you all the cases. So actually, these are all the possible. So we have a lot of shape, as I mentioned, ellipsoid, cone, elliptic paraboloid, hyperboloid, or hyperbolic paraboloid. So you have so many shapes. These are all from the plane, right? Which means a collection of the vector. Depending on, so this is if you expanded it, it's going to be the plane. So you're folded, and then you can find out that shape depending on the length, depending on the size of the width. Or this one, if you expanded it, it's a little bit, you have this cone, and then there's the same shape in the bottom. So every surface, it came from the plane, which means the collection of the vectors. So it's not really difficult. So I'm going to show you the definition of the quadratic surfaces. So quadratic surfaces, this is the equation you can begin with. So this is the equation of that plane. We don't know what it looked like. So ax second power plus by second power equal to 0. So this is a quadratic surface equation, okay? But we are not gonna, find out what the A, B, C, D all the time. Depending on the given constant, right, A, B, C, you can condense it from this long version to this short version, right? And then I'm going to go down a little bit here. So depending on the given information of A, B, C, if you have A, B, C, D, E, F, G, H, I, if let's say everything is a 0, so then you have only J equal to 0. This is a constant, right? But if you have ax second power, dxy, depending on the constant, you can find out the line equation, you can find out the parabola, you can find out the circle, ellipse, and hyperboloid, right? So this is the standard equation where you can find out other line, parabola, circle, ellipse, and hyperbola equation, okay? So these are all the possible. I'm gonna highlight it. So this is the standard. This is the standard quadratic surface equation. Okay, depending on the given constant, we can find diverse shape of or diverse equation of shapes in three-dimensional space. So for example, if you have, so we can, somehow we can calculate this equation, and then it has been condensed, x second over a second plus y second plus, this equation. This equation, show you ellipsoid. And then if you find out that equation, it's going to be the cone. So these are all the possible equation you can find out from this quadratic surface equation. Depending on the constant that they're giving you, you can find out this equation, which is a very, interesting shape. Okay, so you don't need to memorize it. This is going to be given. And then we are going to, find out the corresponding equation and image. That's what I'm going to practice today. So one more time. So this is a more detailed equation as well. So I'm going to show you a couple things for your better understanding. So now you see that, okay, there's a quadratic equation, and then depending on the given information of constant, you can find out other equation of shapes in three-dimensional space, right? So let me give you better understanding, okay? In general, in two-dimensional space, the circle equation, usually we say x second, y second equal to r second. And then if you have a center, x plus minus h second, y plus minus k second equal to r second. So center will be at plus minus h plus minus k, depending on the equation. I'm going to, so this is a cross-sectional image. This is cross-section. So circle has a circle, one, face of the, cylinder. I'm going to look at this one in three-dimensional space. So what happened? You have a couple options. Circle equation can be sphere shape. So the sphere equation, x plus minus h squared plus minus, actually plus y plus minus k squared plus z plus l squared. I'm just creating all the number equal to r squared, right? You can, so sphere is gonna be something like this, right? So when you cut this one, you will find out the circle. Also, you can find out the cylinder equation from the circle, which is x squared a squared y squared over b squared equal to 1. So this is where z equal to the constant. So you can find out the cylinder shape. Okay. So these equation, I'm saying, these equation, it came from also the quadratic surface equation, because depending on the given ABC, it's going to be this equation. Okay, so this is a three-dimensional space equation. You can think about other thing. What else? We can think about the ellipse. Ellipse. So in two-dimensional, ellipse equation is x plus minus h squared over a squared, y plus minus h squared over b squared equal to 1. In three-dimensional space, it is going to be three variable, ellipsoid. We call this is ellipsoid in three-dimensional, x squared, y squared, and we have a z. So this is the equation of the ellipsoid in 3. So the ellipsoid, something like, right? So this is the ellipsoid equation you can think about. Another one, hyperbola equation. Hyperbola equation, it looks like x plus minus h square of a square, everything in 2 dimension here. And then y plus minus h square over b square, that is a 1. In 3-dimensional space, what happened? Hyperbola, if you look at that in the 2-dimensional space, hyperbola is going to be something like that, or something like this. Ellipsoid was like a little bit long shape, and that's a 3 dimension. So in 3-dimensional space, hyperbola has a 2 possible way. One is hyperbola 1 sheet. Here x squared a squared plus y squared over b squared minus, let's see, minus z squared over c squared equal to 1. And then another one, same thing, hyperbola second, which means negative x second a squared minus y second. You don't need to memorize them, it's already given. I'm just showing you all the classification. So hyperbola, if you think about this one in the 3-dimensional space, it's going to look like that. And then two means they are separating. One is here. Another one is in the bottom. So that's kind of like shape. So again, 2 and 3 dimension, they are very similar. In 2-dimensional space, your equation only describe cross-sectional image, whether circle, wide circle, or hyperbola. These are all the 2nd-dimensional image, cross-sectional image. I'm expanding this image into 3-dimensional space. So circle can be sphere cylinder equation, or ellipse can be ellipsoid. Hyperbola can be a cone shape, we can call also this as a cone shape or hyperbola first or second papers, okay? So that's something, what it is. So as I see you, these are all the equations to describe three-dimensional images. Cylinder, cone, ellipsoid, elliptical paraboloid, parabolic, hyperbolic paraboloid. So these are all the equations you can discover from where? This surface equation. You don't need to memorize, just use this table whenever you're trying to corresponding between images and equation, okay? So I just talked about the background, where this equation came from, the surface, quadric surface equation, and then there's a lot of commonality between 2D and three-dimensional space. Let's really take a look at the example, okay? So I'm gonna take a look at the following question. So here we go. I have this equation, 16x second plus 9y second plus 16z squared equal to 144. They say this is a quadratic, this is quadratic equation. And I want to see what kind of shape you will find out in three-dimensional space. So we're gonna solve for, we're gonna simply solve for to find out one of this equation. So let's see what happened. 16x squared, 9y squared, 16z squared equal to 144. That's divided by 144 on both of sides. So if I divide it by 144 everywhere, this is going to be, you can simplify, it would be 9x squared over 9, y squared over 16, z squared over 9 equal to 1. So I found out this equation, and let's find out what this equation means in the table. We have x, y, z, and that is equal to 1. You divide it by that. So this equation, you see that? The first one, when you look at that x second divided by a, y second divided by b squared, whatever, equal to 1. So this is the only case you will find out one with 3 x, y, z variable. So this is, you're going to find out the ellipsoid. And then that's your, there's a center 0, 0, 0, because I don't have HKL, right? So therefore, this is, you're going to find out ellipsoid. Center at 0, 0, 0. So that's your corresponding equation. And then you can think about the image. It is ellipsoid. That's it. The question is pretty simple. The quadratic equation will be given, and you're gonna solve, you're gonna simplify as much as you can, and then match which one is, corresponding to each other. Okay. One more example, 9x second. So I have, this is A. So we have another quadratic equation. So we are same thing. Quadratic equation is a given. And then I want to find out the three-dimensional shape that is corresponding to. So 9x second, let me just find out the same family, 9x second minus 18x. Okay, everything is the same order. 4y second, 16y, 36z plus 25 equal to 0. So let me find out the common factor. So the x family, y family. So 9x second minus 2x, 4, y second 4. And then I'm gonna, because I don't see any z family, let me move this one to the other side, in plus 25 equal to 36z. So far so good. And then do you remember this one? I want to find out the factor. So 9x second minus 2x plus minus, because this is a zero balance, 4y second plus 4 plus minus. And actually, let me make a more space. And then, sorry. So we have a 25 equal to 36z. I want to find out this number. So do you remember? This is going to be, you divided by 2 and half of it and second power, which is 1. So you're going to adding 1 minus 1. Same thing. There's a missing, oopsie, missing y. So I'm going to divide it by 4 divided by 2 and square. You have a 4 and 4. So what does it mean? The first three, that's your binomial factor. So 9 x second minus 1 second. And then I have -1. This is, you have to multiply with 9 to remove the parentheses. So 91. 4, what happened? This 3 is x plus y plus 2 second, and -4 times 4, -16. So I'm gonna simplify. What happened? 9x, there's no x, there's x minus 1. X minus 1 second, 4 y plus 2 second. And if you're adding that number, what happened? -24 plus 25. Actually, it's -25, it's going to be all 0. So we have only 36z. And then what happened? I'm going to make it shorter. So what happened? Now I divided by 36. 9x minus 1. So I'm going to divide it by here 36, 36, and 36. So you have simplify x minus 1 square over 4, y plus 2 second over 9 equal to 0. So this is what I found out after I simplifying that. So let's go up. What is this? This one, we have xy on the left side and z on the right side. So when I look at it, xy, and then you have plus relationship, correct? So this is going to be corresponding to which one? What do you guys think? We have, you can think about it. What do you guys got? What do you guys get? We have elliptical paraboloid, this one, isn't it? And then there's a center we have. So that you got this answer, because we have not the second power for z. So you can be confused between cone. Cone has a z second power. There's no second power for the elliptical paraboloid. So this is, we have elliptical paraboloid because this is only z. So this is going to be elliptic paraboloid center where 1, 2, 1, we have a 2, 0. So this is the center. Okay, so let me go up, 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 up. Actually, there's a negative. Negative is a default. So my bad, -2, 0. So this is your elliptical paraboloid equation. We just found out. So you see what we're doing? The quadratic equation will be given with the ugly, equation. We are trying to find out one of the 3-dimensional equation by simplifying it. Okay, by simplifying quadratic equation, you will find out one of the beautiful, 3-dimensional shape, and then these are all the corresponding equation. So you can see more images here. Okay, so that's how you are solving, and you can also find out the center of that shape. So one more example, let's take a look at the next one. So this is also quadratic equation. I want to find out, one of the, 3-dimensional, corresponding equation. Let's take a look at it. So what are you guys going to do? We have 9x second, x minus y second, z second equal to 9. Let's divide it by 9 everywhere. So it's going to be 9 cancel. So that would be 1 x second power minus y second over 9, z second over 9 equal to 1. So this is your equation. And then find out which equation is corresponding. So we have a 1 on the right side, x, y, z. It's a subtraction relationship. So if you remember, this is a little bit difficult to find out, but this is going to be only the corresponding, what do you guys think? Hyperbola of 2 sheets equation. Okay, right side is 1, and every x and what? X, y, and z is a negative. right? Y and Z is a negative. So you might be confusing between these two. So it's okay, but you can double check. If you have two negative, it's going to be the hyperboloid 2 sheet, which is that image. But if you have everything positive except one negative, this is one negative of the variable. This is a two negative of the variables. So that's a difference. So this is actually, you can say, this is corresponding to a hyperboloid of 2, which means they have a separate top and bottom. Okay, so think about it. You can solve this type of question, in a simple way. So the quadric surface equation will be given, and your job is going to be simplify and match which image and equation are corresponding to each other. Okay, so that's what it is. You can think about it, and 2.6 is a pretty simple, but this is the basic concept. If you're planning to take any physics or any other advanced math courses, you will be able to simulate it in the future. But here we are just learning the basic concept, what the, each interesting, these are all the possible equations that you can found out from the quadratic equation, okay? So the 2.6, you can finish quizzes, and if you have any question, feel free to email me, or I will see you through the discussion board. So keep engaging and working together. I will see you guys in the next video. Thank you, everyone. Bye-bye.